By the end of 2026, AI agents will replace 40% of desk jobs unless you master their stages. And jobs are not really disappearing overnight, but everyday tasks are quietly shifting from humans to software. AI agents are booking travel, handling customer support, coordinating schedules, negotiating basic contracts, and writing production-level code right now. What most people don't realize is that we're still early in how these systems evolve. And where we are in that evolution explains why everything suddenly feels like it's speeding up. A lot of the confusion comes from treating AI tools and AI agents as the same thing. They're not. Tools respond when you tell them what to do. Agents can decide what needs to be done, break it into steps, and act with minimal supervision. That difference changes how work actually happens. The shift shows up in the numbers. The AI agent market was about $7.6 billion in 2025 and is projected to pass $10.9 billion in 2026. Around 7 in 10 companies say they're already using or testing AI agents, while fewer than 1 in 10 have fully scaled them. And about 37% of companies expect AI systems to absorb parts of desk-based work by 2026. So the question isn't whether AI agents are coming. They're already here. The real question is what stage they're in right now. Stage 1, reactive machines. Stage 1 is where AI began. These systems were built around predefined rules written by humans. If a specific condition was met, the system triggered a specific response. That approach worked well for simple, predictable tasks like early chatbots, basic automation, and rule-based decision systems used in customer service or logistics. You can think of classic expert systems or early game-playing machines as examples. Systems like IBM's Deep Blue followed strict logic trees rather than learning from experience. They could perform well in narrow, controlled environments, but only as long as the rules covered every possible scenario. The limitation became obvious quickly. These systems couldn't adapt when conditions changed, and they didn't improve over time. Any unexpected input meant the system stalled and a human had to step in. As environments became more complex, the number of rules required exploded, and maintenance became a bottleneck. Stage 1 systems were useful as assistants, but they couldn't scale into real autonomy. The more dynamic the environment, the more fragile they became. That ceiling made it clear that hard-coded rules alone weren't enough to handle real-world complexity. Stage 2, limited memory. Stage 2 is where machine learning shifted the landscape. Instead of relying on only fixed rules, systems could learn from historical data and adjust behavior over time. This is the stage behind recommendation engines, fraud detection systems, speech recognition, and predictive analytics. You could see this clearly in consumer platforms. Recommendation systems at companies like Netflix improved by learning from user behavior rather than relying on static categories. In finance and security, models began spotting patterns that humans often missed, reducing error rates and false positives. By the early 2020s, these systems were already outperforming humans in narrow tasks like pattern recognition and classification. In some domains, accuracy improvements over rule-based systems reached double-digit percentages. But even with those gains, the systems were still reactive by design. They waited for input. They responded to signals. They didn't decide what to do next on their own. They didn't set goals or plan ahead. If the environment changed in a new way, retraining or human intervention was still required. Stage 2 systems were far more powerful than rule-based machines, but they were still tools. Smarter tools, but not agents. And that limitation is what pushed development into the next stage. Stage 3, theory of mind. Stage 3 is when AI stopped feeling clunky and started feeling useful. Systems got much better at understanding intent, context, and how people actually communicate. Not because they were more conscious, but because models grew larger, training improved, and they could hold more context. You could see that shift around 2023 and 2024. Customer support bots began resolving more issues without constant human handoffs. Writing tools could follow long documents without losing track. Coding assistants started understanding what developers were trying to build, not just the line of code they typed. This is when tools like GitHub Copilot became common in engineering teams. Developers used AI to refactor code, explain unfamiliar systems, and catch issues earlier. Large language models from OpenAI, Google, and Anthropic also improved at multi-turn conversations, adapting tone and remembering earlier context. For many people, this felt like a breakthrough. But these systems still didn't act on their own. They understood requests, but every step still needed a prompt. That became the bottleneck. Stage 4. Autonomous agents. Stage 4 is where that bottleneck starts to disappear. This is where we are now. Autonomous agents don't just respond. They work toward goals. Once AI models were connected to real tools, things changed. Agents could call APIs, access databases, run scripts, schedule tasks, and monitor outcomes. What looks like a small technical shift ends up changing entire workflows. You can already see this in production. Microsoft uses agent-style systems in internal workflows. Customer service platforms deploy agents that triage and resolve common issues. In IT operations, agents monitor systems and trigger fixes when something breaks. In enterprise pilots, tasks that once took days of coordination are being handled end-to-end by a single agent, often in hours. Most companies testing AI agents today are focused on this kind of autonomous execution, especially in customer-facing and operational roles. At the same time, rollout is careful. Only a small share of organizations have scaled agents across core workflows. Reliability and oversight still matter. That balance defines Stage 4. The capability is here, and the caution is real. And once software can act instead of just respond, change starts compounding. Stage 5. Creative collaborators. Stage 5 is where AI agents stop working alone and start working together. Instead of one system handling everything, multiple agents split responsibilities and coordinate toward a shared goal. One agent researches, another generates options, another evaluates constraints, another checks results. Early versions of this are already showing up in research and industry pilots. Teams at Google DeepMind have published work on multi-agent systems where models debate and critique each other before producing an answer. Researchers at MIT have demonstrated agent teams solving planning and optimization problems more efficiently than single agent setups. In industry, companies are experimenting with agent groups for software testing, financial modeling, and supply chain simulations. Instead of one model exploring a problem space sequentially, multiple agents can explore it in parallel. In pilot programs, this has shortened iteration cycles from weeks to days. This stage is often described as collaborative because humans still define goals and constraints. What changes is the speed and scale of exploration. Most projections place broader adoption of this stage in the late 2026 to 2027 range, mainly because coordinating multiple agents introduces new challenges around cost, reliability, and oversight. Stage 6. Artificial General Intelligence. Stage 6 is what most people refer to as artificial general intelligence. This is the point where a system can transfer knowledge across domains instead of excelling at a single narrow task. It could analyze legal documents, write software, and plan logistics without being retrained for each role. No system today meets that definition. Even the most advanced models still rely heavily on training data and struggle with true generalization. But research is clearly moving in this direction. Leaders at organizations like OpenAI, Anthropic, and Google have publicly stated that improving reasoning and cross-domain generalization is a central research focus. What makes this stage different isn't speed or scale, it's flexibility. A general system changes how intelligence is deployed because it's no longer locked into one role. Most researchers place this stage somewhere in the late 2020s, though timelines vary and uncertainty remains high. As systems approach this threshold, discussions around safety and governance have expanded beyond labs into public policy. Stage 7. Super intelligent agents. Stage 7 is where projections become much less certain. This is the point where AI systems outperform humans across most cognitive tasks and begin operating at a level that's difficult to predict or evaluate. There's no consensus on when this would happen or whether it would arrive gradually or abruptly. Some researchers argue it's decades away. Others believe it could emerge faster once general intelligence crosses a certain threshold. What's clear is that this possibility is already shaping policy discussions. Organizations like the United Nations and regulators in the European Union have begun addressing long-term AI risk and governance, even as current systems remain limited. These conversations focus on oversight, alignment, and global coordination rather than timelines. The important point is direction, not prediction. Each earlier stage compounds into the next. Systems move from following rules to learning, to understanding, to acting, and eventually to optimizing. That's why these discussions are happening now, well before this stage exists in practice. Why the stages matter. When you step back, a clear pattern appears. Each stage removes a dependency. Rules give way to learning. Learning gives way to understanding. Understanding gives way to action. Action leads to collaboration. Collaboration pushes towards generality. That's why change feels uneven. Some tasks barely shift, while others transform quickly. It depends on each stage the systems involved have reached. That unevenness often creates the impression that progress is either overstated or sudden, when in reality, it's layered. The takeaway here isn't fear or optimism, it's clarity. Understanding the stages makes it easier to see what AI agents can do today, what they still struggle with, and why adoption looks fast in some areas and slow in others. We're not at the beginning of this curve, and we're not at the end. We're in the middle. Historically, that's where the biggest structural changes tend to happen, before they feel obvious to everyone else. If you made it this far, let us know what you think in the comments.